Welcome. I'm happy to see there are so many of you back, especially after lunch, so let's get started. If you'd like to break down your Rails monolith application and take steps towards making it more manageable, then this is the right talk for you. We'll discuss some of the options you have at your disposal, and then I'll share some action points you can start right away to get you started in that direction. Hopefully, you'll get some ideas from the talk, even if your application is not a monolith. This talk is called Taming Your Rails Monolith. And the main focus is to make working with a big Rails application scalable and feasible for a growing team using battle-tested methods and share a few thoughts on the future as well. We'll spend a bit of time to see if you actually have to break down your monolith at first, and then we'll spend most of our time of this talk learning how to actually tame it, and at the end we'll have a quick discussion about what are some next steps you can take. My name is Mugurel Chirica, but all my friends call me Bud. I'm an internet citizen, so you can find me in those places, but I usually reply to emails, so if you want to reach me. If you want to have a chat or need an icebreaker, ask me why I love the Scottish weather so much, especially the rain. I'm a senior engineer at an amazing company called Simply Business, and at our core, we are a technology company that happens to sell insurance. I do apologize in advance for any company plugs I'll do during this talk. What I'm presenting today is nothing brand new or revolutionary. It's just common knowledge around the subject bundled together. If there is only one thing you can take out of this talk, I hope it's the motivation to take action on anything you find problematic with your application. First of all, what is a monolith? The Cambridge Dictionary defines it as a monument consisting of a single large block of stone. The word is derived from the Greek word monolithos, which means made of one stone, and is composed from monos, which means single, and lithos, which means stone. In software engineering, though, we refer to the word as a massive code base, to the term as a massive code base. Contrary to what most talks nowadays will make you believe, the monolith in itself is not inherently bad or difficult to work with. The most important question you have to ask about it is if you are at a stage when you are actually being slowed down by your massive application or big application. A monolith can be a good thing in some situations. So when you are in your early stages with your project, you have a single application that you can develop fast, and that will help you to stay competitive, especially Rails, which is a very good prototyping tool. It's quite easy to get started with an idea and then ship something to the customer as soon as possible. The most important part of being agile is to get from A to B, where B can mean many things to many companies. As with how software evolves, the road will not be a straight line. It will be more of a zigzag line, depending on how often you have to switch directions to compensate. It is better to have an application that works at this point, even if it means you have to accumulate some technical debt, than having to pivot to another idea or just kill the idea completely and have a lot of time invested in the architecture. The common misconception about Rails is that it does not scale or that it is not enterprise ready. What does not actually scale is the default Rails way, so adding everything in models, views, and controllers. If you architect your application well, you should be able to scale up your Rails application to fit your needs. What is a big application? That's not very easy to find out, especially not by counting the lines of code you have in your application. A code base with 500,000 lines can be maintainable enough for a company, whilst an application with 100,000 lines can not be maintained by another. How can you tell if your application is too big? When the pain of working with your application is too much, as in you are no longer able to keep up with the feature request or maintaining it, and your engineers complain a lot that can't do that stuff with your application, then that's the point where you should think about it as being too big for your company. A monolith can, of course, have problems in itself, but only if you experience some or all of the downsides. So some of the downsides are too complex, it's hard for your engineers to understand your application and work with it, especially for new starters. It's difficult to maintain and add new feature, so there is a lot of effort to fix bugs, to add new feature, to work with the code that is complex, because that's how it's structured, and any changes you do might affect the system in unexpected ways, which might make you fearful to do that change. It is hard to deploy. Deploying your application takes a lot of time, and it can also be very unstable. It's costly to scale. When you scale a monolith, you have to spin up multiple servers for the same full application, even if the traffic that goes to application does not touch every code, it just touches a small part of it. You still have to scale everything. It's difficult to be developed concurrently, and it has shared ownership problems. So you have multiple teams touching the code base, working on the same area of the code, and that results a lot in stepping on each other's toes. For example, it would mean a lot of merge conflicts and a lot of communication that needs to be done cross teams, and that can take a lot of time, and sometimes it can be stressful. It's easy to add technical debt, and it also has critical test coverage. That might mean something from a few tests, so you don't have trust in your test suite, to no test at all, which is the worst case scenario, so you can't even test or trust your test at all, to the more happier case when your application is well tested, but the test itself, the test suite, take way too long to run on any engineer machine, so you have to run it in continuous integration and have a prolonged feedback loop. If you don't encounter the downsides I just mentioned, or if those are not the limiting factor for your growth, then congratulations, you don't have the problem I'm trying to offer a solution for. But please pay attention, maybe you'll find a few ideas for the future. And if you decide that you're happy with your monolithic application, very well, you might as well call it Majestic. The word Majestic monolith is taken from a blog post by DHH, and I think it has a certain pride in it. You have your monolith application, but might as well call it Majestic. Okay, with all that being said, do you still want to break down your monolith, or do you have to? If yes, let's see how you can do that. There are two popular solutions for breaking down a monolith. The first one is extracting microservices out of our application. The idea is to try to reduce it as much as possible to the point of not having one big application, but multiple small applications. The second solution is to modularize your monolith and introduce components. There are a few popular options for this particular architecture, and for the purpose of this talk, I'll focus on component-based Rails application method. That method suggests that you define clear boundary within your monolith, extract those components from those, and at the same time, you still keep the monolithic structure intact. That solution tries to combine the best of both worlds, having a separation and at the same time some of the benefits of a microservice architecture, and also have the flexibility of a monolith. Having extracted components will keep the code separate with the added benefit that you don't have to deal with all the complexities of distributed systems. The solution can also be an intermediary step to extracting microservices. As with everything in software engineering, there is no silver bullet. So everything has a trade-off, and each decision has to be made with all the information you have for your particular context. The direction you are heading with your application is up to you. What I can do is present some ideas and options, and hopefully you'll get other ideas from those. So I don't have a lot of time to get into more details for each of those solutions, or these two solutions, but if you want to learn more, you can just find a lot of resources available online. So what can we do today? Breaking down a monolith can be quite an undertaking. Getting to your preferred destination might take a lot of time, from a few weeks to a few months or even a few years, depending on the size, complexity, and resources you have available. It will also involve a lot of sweat and tears. That doesn't sound too motivating, I know, and might not even be feasible for some companies. So if you think about it as the big redesign in the sky, that probably won't happen. But there is still hope. Introducing components, instead of having everything connected together with no boundaries between them, which is the classic Rails way, helps you separate your code into individual parts of your domain, and you can start working towards making it a more robust architecture. Components are usually either a build gem or a Rails engine, but you can also use external gems or Rails library. Is up to you, but those are the two popular solutions. So let's see the practical steps. We will start at the lower level with the code itself and how to improve that. It is always easier to extract things and separate when we have clean code to work with. To apply these practices and write good code in general, you'll have to do a lot of refactoring with your application, which in turn involves having a solid test suite. So if you don't have a solid test suite that you can trust, or you don't have tests at all, then that would be the best place to start with. Add tests to your application, make sure you will trust your test, and when you do the changes, you will know for sure that application will know for sure. You will be as confident as you can that your application won't break when your client visits it. At Simply Business, we have a community of practice network where we have various groups focused on some specific areas like tech excellence, code quality, and application design direction. Through those groups, we share ideas and knowledge with our engineers, so they all know in what direction we are heading. So if you have something similar at your company, you can use that to share your plans, and if you don't, then you need to find a similar way to communicate that to everyone so everyone will be on the same page. Improving your code base takes time, and you'll need to have a strong business case to convince your stakeholders. Since you don't propose anything radical, like, for example, stopping everything, every feature, adding any feature to our application for a few months, or requiring a big budget to do a rewrite, then hopefully you will not encounter that much of resistance, and your plan would succeed. Engineers should start refactoring with a purpose. So that would be part of your tickets or your cards that you work on, or just because somebody identified the pain point and just created a pull request to fix it. That would help. Encouraging the Boy Scout rule, which means leaving the code base cleaner than you found it, will also help a lot. So for example, if you have some changes to a few related methods when you create a pull request, then why not take a few extra steps and clean that further, introduce some service object or some similar pattern that fits the purpose of that pull request. It goes without saying that you should also delete unused code, so which we call technical debris. You would be amazed at how much code exists, but is not actually used in our application. The code level categories I'll focus on are skinny everything and MVC+. So skinny everything. Back in the early day of Rails, almost everyone was putting all their logic, including business logic, in their controllers, and people soon realized that that is not a very good idea. So the fat model's skinny controllers mantra was introduced as a solution, and then people started moving all their logic to models. After some time, though, we were faced with the same problem, but at this time with the models. So nowadays, the mantra is more in the line of skinny everything, because we want to have small and simple models, controllers, and views. Models represent data in your application. So the default Rails way to use them is to implement the active record pattern, which would mean using the active record gem or Mongoid. And the models themselves that use that pattern handle persistence, even though that is not required. You can have plain old Ruby objects for models, which can be used to define data better and ensure your models follow the single responsibility principle. Depending on how painful it is to work with your actual models, you can consider an alternative to the active record pattern using something like dry RB. Similar to the other parts of the MVC, the view itself can become bloated and have business logic inside of it. In order to make the view simple, it should only be required to display data that's passed to it. For complex cases, you can use the view object pattern, of which there are multiple variations to choose from based on your experience and preference, but the main benefit of using that pattern is that it will help you extract logic outside of your views. The controller should be very simple. Its purpose should be to accept the request, ask the correct object to process that request, and then hand over the response to the correct view. The main idea with making everything skinny is to reduce the complexity of each class and make sure that they follow the single responsibility principle. Extra attention needs to be paid to not just sweep everything under the rug. For example, you move all the code in a mixin or a concern, and we include that, and technically the code is not in that class, but you didn't improve that. So it's better to focus on actually simplify your classes. As discussed previously, the default Rails MVC pattern is perfect for when you get started, and it will help you stay agile. But after a while, you'll find that it is not enough, and putting everything in the default MVC classes is not a good long-term solution. Introducing various other patterns will help you with the previous idea of having everything skinny and simple. Those objects are also easy to test in isolation, and whenever you change something, you don't have to test many parts of our application, just those particular classes. Let's start with services. They can help encapsulate operation and make your classes adhere to the solid principles. Usually the operation is complex, and it involves multiple models and or classes that work together to complete that. There are various implementations for this pattern, so getting started with that might be just as easy as creating a plain old Ruby object and move some of the logic inside it, and then if you need, you can introduce something more complex. Values. rather than passing primitives around and having to modify them in multiple places, it's better to create value objects and use those. They are immutable and implement a contract of sorts, so you know how to work with them in every part of your system without having handling logic being duplicated. Using them also help you define particular concepts that can be easily missed otherwise if you use primitives. If you pass strings around, that won't uncover concepts. A query object is responsible for returning a result based on a specific criteria. Your test will have to hit the database to make sure the data is retrieved properly, but since you extracted queries, you don't need to touch the database for the classes that uses the test, as you would have to do with when testing models. You just stop the queries and making your overall test suite faster. Form objects. They can help us making sure that all the logic that we have and is related to forms stay outside of controls of models. That is where people tend to add the logic by default, and after working with a few models, the logic itself will get messy, and it will get messy. Adapters are one way to convert a DSL to another, either internal to the application, for example, between namespaces, or for external dependencies. The benefit of using them is that you don't have to leak implementation details between systems, you just have to keep your public API stable enough. Your internals can change without any effect for your consumers. Within the system, adapters can be used to prepare for future extractions of components by forcing you to design your API. If you don't know exactly where to start applying those patterns, a very good bet would be to start with your models, since that's where most engineers add code by default. The next good bet would be your controllers. So start with the easy thing first, and let your engineers know that you are deviating for the standard Rails way. If you don't mind the challenge and want to get the best return on investment for your time and effort, look at the areas of code with the highest churn and improve those. When a class has high churn, it means that it does change a lot. You can use automated tools or services to detect that churn, and then you can decide on which part to get started. Let's have a look at the organizational level. Introducing the previous concepts to your code base might take a while, and they are an important step towards the end goal. So once you reach that, the next level will be to improve the organization of your code. Keeping your organization separated by domain is the first step toward both the microservice architecture or component-based application, and can be sufficient in itself for some companies. So in order to do that, we'll use the strangler pattern. The strangler pattern definition is incrementally migrate a legacy system by gradually replacing specific pieces of functionality with new application and services. So the idea is that we want to gradually replace our existing code. So what can we do about that at the organizational level? First of all, you should stop adding new pieces of functionality. Whenever you had to add a big functionality to the monolith, whenever you have to add a big piece of functionality to your project, start creating that in a separate context. So if you are not under critical deadline pressure and you have the people power necessary to do it, you can start adding a new component right away, even as far as extracting that as a fully-fledged service. If you don't have that luxury, though, you can still adhere to the tight schedule you have or other limitations, but still preparing for the future by introducing components, but within the monolith itself. Separating the backend from the frontend. Once you get to the point that your frontend is too big for and complex to be managed by any of your backend engineers, and you actually have dedicated front-end or full-stack engineers, you need to separate your backend from your front-end. Your front-end engineers should not be able to understand the backend unless they really want to. So if you separate those two, people that are specialized in a particular area can do the work that they are that can do best independently. You can use various patterns to separate those. For example, you can use the backend for front-end pattern if you have multiple API consumers, like mobile applications and a web interface, or you can just use plain old APIs for your website. Identifying the components within the system is the next step. So Rails is just a framework, and you are building an application that covers your use case, and that happens to use the Rails application. So your application is not a Rails application. That, if you look at your folder, you should see a reflection of what you're doing. For example, if you are an insurance provider, that should be cleared from your architecture, from your folder structure, sorry. Or if you're doing a streaming service, etc. not necessarily that you use the Rails framework. Actually achieving that goal is pretty difficult, so that might be like a stretch goal, but we can also start going in that direction by structuring our application for the future. So when you started your project, most likely you were not aware of what you needed out of your application. Your domain was young and missing a lot of details. So with the passage of time and you getting more information about your domain, some parts of it are actually mature enough that they can be identified, separated, and possibly extracted out of the application. The first step would be, of course, to identify those concepts and delimit them in your application by looking for seams. Seams are places where two or more parts of the software meet and communicate with each other. Adding components to your application will still have the same end complexity. You will not remove code, you will just organize it differently. But it will be easier to get a better understanding of each component and get started working on it, especially for new joiners. So when you have a monolith, when somebody new joins, they'll have to understand most of the monolith in order to get stuff done. But if you have a compartmentalized application, they just need to understand the particular component. They also have separate namespaces, and you should be able to prove that a particular component works without touching all the components, and that would help with your test suite and development speed. Feedback, sorry, the feedback speed. At the boundary of the system, you can use the data mapper pattern to avoid unnecessary coupling. So for example, instead of passing the active record object itself, you convert that to a value object and you pass that around. So this is called the anti-corruption layer in domain-driven design. At this point, you should have identified the components you think they are possible to extract because they are mature enough. So once you did that, the next step is start extracting new components. To gain the full benefit of extracting components, you should also make sure you migrate the table names to include the component namespace. That will make it easier for a future extraction. Extracting the smaller components outside of our application can be completed in a logical progression. Start with identifying a component, maybe move the code to a namespace folder. Then you extract that to an unbuilt gem or a Rails engine. After which you can transform it into a fully fledged service. Any component is unique, and depending on the size of the complexity, you can skip some steps in the process. Each level will, of course, have increased level of complexity, and you'd have to decide if you can skip some of them and, for example, extract a service directly. Like I mentioned previously, there is no silver bullet, so you'll have to decide for yourself. The principles are the most important, are more important than the implementation, because any particular implementation will change over time. So what is next? Assuming that you have separated your monolith as much as possible into components and maybe extracted a few separate services, you need to plan what to do after that. If the state you are in at that point in time is working well for you without slowing you down, or without slowing you down your progression, then that's good. You can stay at that level for as long as it's possible. If that's also, you need to make sure that you follow those principles, because otherwise you'll get back to where you were before starting introducing those patterns. If you still think that you need to separate the application further, you can choose one of the next sensible progression. For example, moving to a microservice architecture, or anything else that would happen at that point in time, and it's a good thing to do. In summary, if you want to break down your monolith, start at the code level. Refactor your code to make it easier to work with by introducing some or all of the mentioned patterns, and then start identifying components and extract them within your application. Once you have your Rails application modular, you can then decide if you want to take a step further or keep your application in that way. I will mention a few resources. So the Component-based Rails application website has a lot of good resources you can check out. I won't list them there, but if you visit the first link, you'll find it there, including talks, videos, books, and articles, and all that. And the component-based Rails application book that I showed over there gets into a lot more details of how to practically do it, from generating engines, from converting those to components, how to deal with multiple migration and stuff like that. So it's very detailed if you want to see how to actually implement that pattern. And if you are interested in the microservice pattern, Martin Fowler's article that's linked over there, it's a good place to start. If you want to see some practical step-by-step examples, there are a few Rails Rails and Ruby applications that have more than 300,000 lines of code, and they follow some of the patterns recommended here. For example, you have GitLab and Mastodon. Those are two good examples, and you can look at how they decided to tackle some of the problems. And you can obviously look through their documentation and their commit history and see how they managed to do it. And there are also a lot of talks on YouTube about some problems that companies faced when evolving their architecture, and a few good examples are Netflix and Airbnb. There are a lot of talks and articles by them, and they have problems on a different scale, but I think some of the principles still can apply at any level. So, and like I said, you can also find a lot of examples online if you just do a quick search, and there are articles and books written. Whatever your next goal will be, there is, of course, a lot of effort involved. So you'll have to choose the right solution, the right tools, to level up your engineers, to make sure that everyone is on the same page, to get buy-ins, etc. But all that effort would be worthwhile, and your application at that stage would be modular enough that you'll have less problem to deal with in the future. So thank you very much for your time, and good luck with taming your monolith. Feel free to get in touch if you want to talk about anything. And are there any questions?
Any questions?
Hello.
Yes.
Thanks for this talk. It's very interesting and useful, I find it. So can you tell us some the go-to approaches that you use at your company? So among those that you described.
I'm pretty sure most of them, if not all, is what we use at our company, or we try to use. I don't want to oversay it, but for example, with the view model pattern, that's something we use a lot, and other patterns like queries we want to use more of. And the microservices step, so we have some components defined within our application, and we're working toward extracting services because we have decided as a company that that is the next step for us. Our application is modular enough, but it's slowing us down, so we're moving towards microservices. But to answer our question, I would say a bit of all of them, and some of them we use most of the main concept.
Thanks. And what about dry-RB ecosystem and maybe Hanami? Did you consider using something like that?
Dry-RB, not yet, and Hanami, we don't have a case for it, but if, for example, we'll have a service that needs an application, we can have a look at that. The problem we have is not a lot of us know Hanami, so we'll have to actually get buy-in for the new framework and decide if it's worth the effort to train all our engineers to use that. But if the effort is worthwhile, then yeah, we can probably use it.
Yep. Thank you.
Thank you as well.
Thank you. Any other questions? Yeah, we have one.
Hey, thank you for the talk. I would like to hear some of your thoughts about interactors. What do you think of them? Should we use in our applications
Interactors is similar to the service object pattern. I've heard about them, but I don't think I use them. And we might use them in our application. We have a big monolith, so I don't know. What is an interactor?
Well, they is like a place between model and controller, somewhere between model and controller.
So it's probably a variation of the service object pattern?
It's something for separating business logic.
Yeah, I don't know the answer, but like with some of the patterns, you have the core idea, and there are a lot of variation. For example, with the view model, you have like for presenter, view MVVM, and other stuff like that. So
as I know, interactors came from Hanami architecture, and as I know now, there is some gem called interactor, and it can be used in Rails application. Okay. And it's a pretty cool technology we are using in our projects.
I'll keep an eye on that. I hear Hanami mentioned a lot, and there is a talk about it, so I'll keep my eyes opened. When is that, tomorrow? Or today? Hanami? Tomorrow, yeah. looking forward to that.
Yeah, another one question, please.
Hi, thanks for the talk. So I have one question: is how do you guys separate your domain logic in your application? Is it still split? If you have this one monolith, is it still split into those different modules and separated, or do you tend to move towards policies?
I don't think we use policies. We use policies is when you have the one that is the pattern when you decide if you are allowed to do a particular action.
Yeah, I mean yes, but
Yeah.
in my case, in our application, we use this to this naming scheme to determine the domain business logic and to basically separate all the business related interactions into those policies. So for example, we have services which then interact with policies. So whenever we want to actually change the business logic of the application, we just need to modify certain values in those models.
Yeah, okay, I get what you mean. I don't know if we use policies per se, but we definitely don't keep business logic in controllers and models. We keep them in a variation of the patterns I described, and we have some components that are just separated, and we use those inside those, and we have classes. They can be like plain old Ruby classes, but they only deal with logic. So
yeah. So I guess the gist of my question is: do you still have this segregated into multiple different services, modules, and components?
yeah,
But okay.
no.
Have you thought about moving towards this other approach where you have this logic for the business related logic in one place, and then the services, queries, and everything interacts with it?
I don't think so. I mentioned the community of practice stuff. So, for example, if somebody mentions that, now that you mentioned it, I'll probably write it down so I have something to discuss at one of the next meetings. And yeah, we can discuss it. Usually, if it's something that helps out and it's the time investment is good, then yeah, we can probably use it and see how it goes. That's what we do with a lot of patterns. Some of them at first seem, oh, this is a lot of extra work. We don't want to do it. But after a few weeks or months of doing that, oh, why didn't we do this a few years ago, right? And stuff like that. So we can definitely investigate. You said policy, no?
Yeah, policies.
Policies and interactors and Hanami.
But I guess
I was the recording and I wrote everything down to discuss.
Yeah, I guess every one of us had this time when we thought services are weird. So
Yeah.
Okay, and last question, I think. Yeah, please.
Yeah. Hi, thank you for your speech.
Hello.
So I have two questions. The first one, who was this guy who asked this question? Because I think...
The last question?
Yeah. Well, because, okay, thank you. And my question is, what do you think about implementing the domain events pattern in component-based architecture? So
we're actually working towards that. We have a few systems that are separated from our monolith that use domain events, and I think is event sourcing? No, that's something else. We use that as well, but yeah, there is definitely, they use domain events. I don't know that many details because it's a separate application, which is separate, and it's good that I don't know because I don't have to keep that in my head. But we're also working towards that with our main application. So I think recently we got into the process of actually using more domain events. We used it a bit in the past, but now we have like some fully quarter work that we want to do around that for some of our systems.
did you implement it in Ruby or in other languages?
In Ruby, because our monolith is Ruby.
And what gem did you use for this? I think, because I know only one, Whisper, I think it's pretty
I don't think we use the gem. We'll see in the next quarter. I can answer that question of what we used and all that. So we started working towards that like a few weeks or months ago, and we're still in the process of using more of that. But at first, the solutions we already have is just plain old Ruby.
Yeah, okay.
They're not too complex, as you can tell. Yeah, thank you as well.
Yeah, thank you, Mugurel. Thank you.